We're going to talk about a couple topics today. I'm going to try to run through the first three topics here, and we'll leave a lot of Q&A session at the end so you guys can talk, ask your own questions. So as we go through this, just formulate the questions and we can go over. I have about 40 tweets that have been asked of me between yesterday and today, so I'll try to get through some of those, and then we'll open up the floor for your own questions. But I'd like to just kind of quickly talk about why Google switched to machine learning based search, how machine learning based search actually works, and how we actually can use AI today to actually uncover how this machine learning based search works. And so, you know, if I was a Google search engineer and I was up here trying to answer your questions, this is about as much information as I would be able to give you. They're under NDA, so they're never going to. If you're thinking you're getting real answers from Google's representatives, you're really not. They have a whole team that is basically just to placate the SEO industry to tell you things so that you don't get too upset. But a real answer from a real search engineer, a real question to a real search engineer has yet to be ever answered. I've never seen it. So I've been building search engines for 15 years. I actually built one alongside Google, sort of in parallel, as a way to model Google. And so I guess I'm trying to sort of fill that role to the SEO industry is, you know, whatever project you're working on, whatever part of marketing you're working on, if there's like a missing piece of information that you're looking for that you just wish you could like get that answer from a real Google search engineer, I could probably get you really close. So that's sort of what I'm trying to do today. So just really quickly about me, I co-founded Market Brew in 2006. I'm a Google for Entrepreneurs advisor, and funny story, I've got patents that Google references, we kind of share the same space. This is me unboxing my first computer, 1983, so I was 6 years old, and so I learned how to code really quickly. I got the code bug bit me really early on. Had to program my own games. They didn't come with, you know, like cartridges that you put in there, so you had to actually have a book and you program the games, and the power would go off and then you lose the game and you have to program it again. So that's basically how I started off. Later on in life, I was building large-scale systems for trading systems on the New York Stock Exchange and NASDAQ. And in 2006, I actually met a couple of business owners that sort of learned how to decode Google for their local market. And so I essentially took them national. I sort of replicated it, brought it to scale, and it was sort of my first introduction to SEO, what SEO was. I unleashed the first major link network, I believe. In fact, I believe that the supplemental index was sort of a response to what we did. And I kind of learned the hard way that this was really not a long-term business strategy. So I decided to switch teams. I wanted to show others why this approach, trying to play this sort of hacking Google, was a sort of a pointless short-term approach. And I wanted to really show people that weren't programmers, that weren't technical people, how Google actually worked, how a real modern search engine actually worked. So I got to programming over the last, probably the first 2 or 3 years. I didn't really sleep. I worked about 120 hours a week. I have a number of patents on this idea, this concept of sort of a search engine optimization engine. And essentially what it is a sort of a new type of search engine that isn't used for what you would use Google for. It's really used to introspect on how Google actually works. So we had to build all the components. We started building our own crawler. You know, in 2006, there were no open source libraries or APIs, so this was before Ahrefs. Open Site Explorer. It was even before Yahoo Site Explorer. So we had to learn how to build a lot of components that were not available at the time. We had to model a lot of the families of spam algorithms. I always talk about how we sort of got a cheat code to this because we started early and we were able to isolate every new type of algorithm that Google would add to their search engine. So we had already kind of had a collection of very basic algorithms that we were able to understand. And then as things became more complex, we were able to know exactly, you know, what was the gap in our search engine, what was the gap in the model, and fill that in with the new algorithms that were coming on board. So our first version of search, just like a lot of the search engines, was a rules-based search engine. You had algorithms that you coded up, and they're all rules-based. In 2013, we actually switched to a machine learning-based search engine where we sort of anticipated Google removing a lot of the data from its search engine, or at least the output of what you see out of a search engine, and essentially build what was like a generic search engine that could be manipulated to calibrate itself to behave the same way as any search engine that you pointed at. So effectively, we used a genetic-based algorithm, which we'll talk about in a bit here, to take this rules-based engine and turn it into a machine learning-based engine. So this was sort of the key milestone for Market Brew, was basically building this new type of generic search engine that could clone itself. You could point it at any search engine result page, and essentially it would learn the bias and weight settings on the relationships between all of the algorithms inside of the search engine. So why did Google switch from a rules-based to a machine learning-based search engine? So algorithm equations used to be really simple. A lot of you who go back way back early 2000s know this. It was fairly simple to classify. If you had two different types of websites, some in the blue, some in the orange. It's a pretty easy way to do this. It's a linear line. You can draw a line between the two and classify these sites as good, these sites as bad. But as the search engines evolved, they became very complex. So now you have to define some sort of equation that puts all the orange in one classification and all the blue in another. And obviously you can do this. You could write a rules-based equation that had this 2 pages worth of an equation to define what the separation between these sites were. But really it becomes a nonlinear classification problem. It's not really a legitimate way to approach the more complexities of classification. So we need to solve these complex equations, and how do you do that? There's no human that can actually come up with these equations that work for all the sites. So neural networks actually became one of the go-to ways of writing these equations. So essentially the neural networks, through machine learning, they would train this data, and we'll talk about a little bit about in detail, but this would give us sort of the equation. And you can see right here, this is a neural net that's learned how to separate the orange and the blue here. So this is kind of a neat little spiral effect right here in this graph. That's an actual equation that it's found to separate the two different types of sites. So with neural nets, you can do a lot of really cool things. So Google's machine learning version it's what we call supervised learning. So in supervised learning, humans are always assigning labels and features to data. So the labels would be more like, is this site spammy, or is this site good quality content? It's essentially the output of what their search engine wants to be. And the features are essentially these rules-based algorithmic outputs, right? So they have these rules-based engine or rules-based algorithms to define how good link structure is and content structure, whatever you want to think about inside of a search engine. Essentially, all these rules-based engines, and then these become features to learn the relationship between the features and what they want the output to look like. So that neural net, in the supervised learning process, what we call training the model, iteratively learns these relationships between the two. How do they label the neural net? Well, there's a thing called the Search Quality Rating Guidelines, which many of you have already heard of. And this is essentially the way that they had humans label their machine learning. So essentially, they would give a list of guidelines of what is a good site or a bad site, a good landing page or a bad landing page, and they would work backwards to learn what the relationships and the bias and weight settings of each of these rules-based algorithms inside of their core engine should behave. So the problem is that SEO platforms really haven't caught up to this. So Google made this switch sometime around 2013 when they really got into identifying pictures. They used things called convolutional neural networks to do this. and they said, hey, this might be applying to help our core engine behave a little bit better. And so they switched over sometime around 2013. And as of 2021, we estimate 95% of SEO platforms still use a rules-based paradigm. So there's a huge gap in the way that people are thinking about SEO today. And so I'm trying to shed some light on why we want to use AI to understand what the AI is actually doing. Peter Norvig made a really great quote, Google research director. This was many years ago, but still stands today, that it's all about running experiments and using statistics and not logic to analyze the results. And that's really a lot of the ways that they introduce new algorithms, or they try to tweak the core algorithms inside of search. They're not really going in and manually changing algorithms. They're relying on these statistical analysis to reweight and bias some of these algorithms. So as SEO professionals, you guys really want to know what is inside the black box. That's the whole purpose of sort of understanding what we're trying to do here. And so the first thing you got to know is that the black box is constantly changing, right? So from one day to the next, depending on how often that they retrain these models, and from one search engine result page to the next, one keyword to the next, all of these are constantly changing. And so the other thing is that the search engineers, me included, can't always give you a straightforward answer. If you ask me, why did this site rank better than another site, I have to go in and statistically look at things and analyze them. And it's not as simple as saying, well, it's this algorithm and it's doing this. And the reason is that you've got this neural network that it many times has millions of neurons that essentially are these bias and weight settings on the model. And it's really not very straightforward to get from the outputs of these algorithms to how the rankings end up. So those two things combined, that sort of understands why people don't understand what that black box is actually doing. But it turns out you can actually use AI. You can use their own technology, right? Google used AI to improve their search engine. So why can't we actually use that same technology to infer and understand how that actually works? So it turns out you actually can, with sort of taking it up one level higher. So where the labels become the ranking data, right? You can use a ranking API to list out how that keyword is behaving in that search result page. And then the features become sort of the algorithmic outputs of this black box. And so where do we start? The first thing we have to do is create sort of a generic search engine. We got kind of lucky because we started in 2006. Like I said, we were sort of grandfathered in, so we weren't able, if I were to start this now, it would be quite complicated to try to come up with what all the algorithms are inside of a search engine like Google. But it's still doable, but it would be a lot tougher. One of the ways that we determine which algorithms to model is breaking it down into first principles. So you probably have heard this over and over by people like Elon Musk. But essentially what we're doing is we're not reverse engineering the code, right? So we can build search engine models to understand what's in the black box. That doesn't mean that we know exactly how the code operates, but it's sort of an approximation of all the key components that are behaving inside of this black box. And so starting with these sort of first principle algorithms, sort of modern version of PageRank, duplicate content, Panda, Penguin, those types of algorithms. And as we start developing this generic search engine, you can actually use machine learning to determine sort of gaps in the model and fill it, and how certain algorithms may be missing, and explore how to fill those in. Quick warning, you've heard this a million times already, correlation does not imply causation. It's absolutely true. However, correlation is pretty interesting here. It can actually establish relationships, which helps us uncover a lot of things about this black box. So there's, obviously there's a study where it was kind of a funny study where they said TV sales correlated with deaths, right? So the more TV sales increased, the deaths increased, but obviously this just means that the growing population means more TV sales and more deaths, right? So that's very simply explained. However, if you have a relationship defined, in that relationship, that correlation starts to unwind, right? some new factor typically is the reason why that correlation has stopped working. And so the fact that you can establish a relationship and monitor that relationship through time, and as it changes, it kind of signals that, that some new factor has disturbed the correlation that may need investigating. So here's an example of an overly complicated model, right? One of the dangers of trying to emulate something as complex as Google's black box is to make your model too complicated, right? Can you make an equation that separates all of these orange dots and the blue dots representing two different classifications? Absolutely, right? We did it right here. There's a neural network that has come up with an equation that works perfectly to fit this data. But what happens if we add new data to something like this? You get this, right? So it's obviously not fit. The new data does not fit the previously trained model. And the reason why is that there's too many specific or low-level algorithms that we're trying to use as features in this process. So we don't want an overly complex model. We want to keep it simple. The less complex a machine learning model, the more likely that a good empirical result is not just due to the peculiarities of that data set, sample set. This doesn't mean an overly simplified model. You can have a top level of features or algorithms that represent many different complex calculations underneath them. Sometimes many hundreds of sub-algorithms that may calculate that, but it doesn't necessarily mean it. It just means that we're preferring a feature set that explores just the top layer of algorithms to emulate. And also, we don't want to have one algorithm overwhelm the model and take over the model essentially and represent most of the movement in the model. So we use things like weighting ranges and L2 regularization. So this is basically some of the things that you get tripped up on when you go through building these types of models. So what are the benefits of modeling a black box, right? So the first benefit, obviously, is very accurate. It's pretty much the most precise way that you can understand what's happening in any individual search engine result page. So think of it as sort of like a search engine that can calibrate its own settings using machine learning to behave like any search engine that you want. So we have this generic search engine, we can point it at a search engine result page, and we can run through this process, which I kind of skipped over today. It's a little bit complicated to go over all today, but we use a genetic algorithm called particle swarm optimization. And this allows us to take the generic search engine with all the different bias and weight settings and figure out what a global maximum solution is to emulate exactly what we see on the target search engine. So once we have that, we have sort of a calibrated search engine simulator, if you want to think of it that way. There's different ways to name it, but that's what it is. And this gives us really good predictability, and of course the opposite of the risk avoidance features as well. So it allows, once we have these calibrated models, it allows you to make changes, whether that's content changes, link changes, anything in the spectrum of SEO. We can run that through these models, and we can sort of predict what's going to happen when you introduce those changes. Today, what you do is you deploy that to a production environment or to the website, whatever, and Google comes around with its crawlers, crawls all that data, and a couple months later, it all filters out into the ranking algorithms, and either your rankings go up or down. If you didn't isolate those changes, you have hundreds of different changes that you may have just made. There's no real way to actually understand what was a good change and what was a bad change. So with these models, you can actually isolate this. You can make tiny little changes, run those changes through the model, and you can actually understand what that individual change to your site did to your ranking for that landing page, and even other landing pages. And of course, it just gives you a little bit deeper understanding of what's going on inside of the model. We can do things like understanding statistical gaps in the model. We can compare the outperformer. We can actually find the outperformer in the model for every part of search. So we can find the site that does really well with meta titles, site that does really well with content, sites that do really well with the link structure, internal and external. Anything that you can think of, we essentially can identify what those outperformers are. And if you're trying to move up in ranking for that specific keyword, you can basically, instead of emulating the #1 site in that search engine result page, which typically isn't always the first #1 site in every part of the model, instead you can kind of just look at exactly what the outperformers are and go after those for each part of the model. So the concept is really just we want to rethink the way that we do SEO. We don't want to be in a rules-based paradigm. We want to start employing machine learning and AI to actually understand what's actually happening inside this black box. All right, so the end part is I want to kind of go over a Q&A session, but I have about 40 tweets that just got sent in, so I want to go through some of those. So just kind of think of your questions as we go through this, and I'll sort of, once I get through this, I'll kind of go through any questions that you guys have. And at the end of this, if you guys want to see this in actual practical action, come up to me and I can set you up with like just a sort of a freebie, whatever website you want to look at this. And we can build a model for you, and you can see for yourself sort of how this works, if it's interesting or not. So, all right, so let me start with some of this first tweet.